Okay. So if no query for the OMP, then let's continue with the next part, which I told you that today we'll continue with the BFD and then the IPSEC one, right? So the first one is BFD, right? So do you have any idea about the BFD from traditional network?
Yes, I have.
Tell me.
BFD is a bidirectional forwarding detection protocol, which is used along with other protocols to help detect errors and converge the protocol faster. For example, a BGP has a timer of 180 seconds, but if we use BFD, we can speed up the convergence and we can detect the flaws and errors and rectify the issues.
Okay. Which kind of errors and issues are rectified via the BFD?
Link down issues. Suppose if it takes 180 seconds for the BGP to detect and resolve the issue, for the notification to be sent, that it takes 180 seconds. But with
Right.
help of BFD, we can do faster convergence, detect the link down issues earlier, and do the calculation and make sure that the link down timer has been minimized.
Okay. So the same thing is being done for here for T-logs, and it impacts the OMP, right? So the same thing is not directly being done on OMP, it's directly being done on T-logs, right? So when we are in SD-WAN and when we are talking about, you can say about the BFD, so we say it is impacting the T-logs,
Okay.
right? So the same thing is for the T-logs, but T-logs are directly proportional to what? OMP, right? OMP, it's directly being done on.
The link down has been timer has been minimized.
Okay. So the same thing is being done for here for T-logs, and it impacts the OMP, right? So the same thing is not directly being done on OMP, it's directly being done on T-logs, right? So when we are in SD-WAN and when we are talking about, you can say about the BFD, so we say it is impacting the T-logs,
Okay.
right? So the
Yes.
same thing is for the T-logs, but T-logs are directly proportional to what? OMP, right? So whatever you have seen it for the BFD in the traditional network, the same thing is there for the SD-WAN, right? So it is
Yes.
detecting failures, right? It is helping to establish IPsec tunnel, right? It is helping to find out the fault, but which fault? The fault which is there on underlay, right? Since the SD-WAN is what? It's an overlay technology, right? It's doing everything most probably on overlay, right? So when we say OMP, it's an overlay protocol, but TLOC is underlay, right? TLOC is a terminology of SD-WAN. But when we look the TLOC, what is the TLOC? Any idea? What is
It
TLOC?
is the transport locator, ma'am. It is the link which is terminated on the VH devices, which is used for connecting the underlay devices for IP reachability.
For IP reachability. If you remember yesterday, I showed you that OMP is also updating all the TLOCs to vSmart, right? So OMP is updating all the TLOCs to vSmart, whatever is available on a VH. So let me share my screen first. Over the screen, I'll share the topology. So Sharon, I will show you the other topology in some time before ending the session, since this topology is already turned on, right? Otherwise, I need to turn it off and then I need to show it to you. Okay. So just allow me some time. I'll answer you or I'll show you that the second topology, right?
Noted, ma'am. Thank you.
Fine. So now proceeding here with the parameter, the T-lock. So when we say T-lock, T-lock is here on a VH. So if I say this is the VH1 of site 1, you'll be able to find the T-lock here. So this is, we say here we have the T-lock. Now what is this T-lock? T-lock is the combination of, we generally used to call it what? Transport locator. And it is the combination of three things. What are those three things? The first thing is what? System IP of the VH.
Encapsulation and color.
Then the color of the VH by which it is connected to the ISP. And then what encapsulation which we have configured on the interface. The color encapsulation, we have both the things we have configured on the interface. And that's what belongs to what? T-lock. Right?
Got
Then
it.
each T-lock will have a IP address as well. Each T-lock will have a IP address as well. Now, sometimes what happens, we configure NAT. We say public IP and private IP. And if there is no NAT configured, the same IP will be represented as a public IP and private IP. Now here in this scenario, if you will be able to see between the MPLS cloud and this VH1 site 1, the subnet is 20.0.0.4. So there might be possibility 5 or 6 IP might be configured on the VH1 site 1, right? So that particular IP will be the TLOC IP address. And that's what is being reported to the vSmart from this VH, right? So now the connection between this VH to ISP is being defined by the BFD. So if BFD goes down, TLOC will be down. If we look at BFD and BFD says what? The BFD is down or the BFD is working, or how the BFD works. BFD works on this underlay, right? And as soon as this underlay goes down, when I say underlay, this is the underlay. This is the underlay, right? The interface. We configure the IP, we define the static route, right? Or whatever the way the MPLS cloud is connected to this VH, this is what we will be able to see the BFD. And by default on SD-WAN, we need not to do any configuration for the BFD. So if I come back to the here, come to this particular part, monitor network, you'll be able to see that this particular VH is having what? 2 BFD sessions. It's supposed to have 5 BFD sessions, but it is connected with 2 BFD sessions. Why supposed to have 5 BFD sessions? Supposed to have 5 BFD sessions available based on the topology. One BFD session is towards VH1. To site 5. It is up since it is connected with same MPLS cloud. Second BFD session is towards site 2. This one is also up since it is connected with same MPLS cloud, right? So it has 2 BFD session what? Up, right? Rest, if we'll be able to see that there are 3 more session it has to establish, but all those 3 sessions are not connected with same ISP. All those 3 sessions are connected with what? Different color, different ISP. Hence, all these 3 BFDs are what? Down, which is not up with this VH. So, how the BFD is what? BFD is tracing the connectivity. Which connectivity? Underlay connectivity from one VH to another VH. BFD does what? BFD is tracing the underlay connectivity. From one VH to other VHs. Based on the TLOC information. Based on the TLOC information. So what is the TLOC information? System IP of the VH, color of the VH, and IPSEC encapsulation of the VH. And if BFD comes up, then IPSEC tunnel is established between those two VHs. So if you will be able to see here from site 1, when it is tracing the BFD connectivity to site 5, color and encapsulation was same, BFD is up. Wherein, if you will see it on VH site 2, there are two T-locks. With one T-lock, the color and IPSEC is same, BFD is up, but with other, there is a difference in the color, BFD is down. Is it okay? Is it okay, guys?
Yes, it's okay for mine.
Yes, ma'am.
Right? So what exactly, if we talk about it, in a one-liner statement, if I talk about BFD, it is a lightweight protocol. It is not heavy. We need not to do any configuration there in the SD-WAN network related to BFD, right? But it provides fast detection of path failure, right? It actually provides what? Fast detection of the path failure. Which path failure? Between one VH to other VH. You can see it right now in our topology. We can see that it is detecting there is a no reachability between VH1 site 1 to site 4. Since they both belongs to different ISP, different colors are configured. Hence, it says that BFD is what? Down. And once the BFD is down, what? There is no IPsec connection established. And how exactly it is doing that? It is actually exchanging small hello packets between, you can say that between these two parameters, right? So what it does, from site 1, it'll send a small hello packet to all remote sites. It means to site 5, site 2, site 6, site 4 on every TLOC. On every TLOC. Since site 2 has 2 TLOC, it'll send to every TLOC. Now, how it has received the information of other TLOCs? It has received the information of other TLOCs from vSmart. Since vSmart has updated, OMP has updated the information of the TLOCs, it has all the available TLOCs. What will happen? The BFD will be initiated. It will send a small hello packets to all the TLOCs, and whosoever TLOC will reply back, it will establish a session with that. Okay, so it is actually running on the top of what? On the top of UDP and IP protocol. It is not having its own, you can say that architecture. No, it's not that it'll run on a transport. Since there is no transport, it means there is no IPsec connected right now. Before the BFD, first BFD has to come up, then the IPsec connection will be established. Right? So it is not using any set of transport. It is just sending the hello on the T-locks which is being received via the vSmart. It means via the OMP. Right? So we have seen yesterday, as soon as there will be a control connection up from VH to vSmart, there'll be a control tunnel created between VH to vSmart. And as soon as the tunnel is up, there'll be a TCP session will be up on port number 17900. Then after that, OMP hello, OMP handshake, OMP update. And from the OMP update, this VH is going to receive the T-locks. Whatever the T-locks are being received by this VH, it is going to send a hello. BFD is going to send a hello to all those T-locks. From some of the remote T-locks, it is going to receive the response, and from some, it is not going to receive the response since they are using the different color. Or there might be possibility same color, different encapsulation. Since I showed you that there are two possibility of the encapsulation, IPSEC and GRE, and the default is IPSEC, and we prefer to have the configuration of IPSEC. Okay, so all the T-lock parameters needs to be matched except the system IP, since system IP is the unique parameter, which defines it's a remote T-lock. But color and encapsulation needs to be matched. So once the color and encapsulation is matched, the remote T-lock will also respond to that hello message, and then they are going to establish the BFD sessions between the remote sites. Are we okay?
Yes, ma'am.
So generally, if I come back now to this QMO, if we see, this is what the VH, right? So if I come to the configuration, devices, under the devices, I'll be able to see the WAN edge list. So here, if I see it, what? VH1 site 1. Under the configuration devices, if I click onto these three dots, I can see the running configuration and the local configuration, right? Running configuration and the local configuration. So if I look at the running configuration, if you'll see it here, this is the system configuration which we have configured it, right? Then it has what? AAA default configuration, right? And after that, it has OMP default configuration. No shutdown, graceful restart, advertise connected, advertise static, right? OMP is going to advertise the connected and static route, right? Then further, we can see the default IPsec policy, right? After that, you will be able to see the VPN configuration for the interfaces, static routes, right? VPN 10 is configured. There is no configuration for VPN 512. And this is what the configuration which we can see it, right? So this is the running configuration. Now, If I look at the local configuration, similar way, the way I've seen what? The running configuration, similar way I can look at the local configuration. Under the local configuration also, you'll be able to find few differences, like you can see the personality of the VH, model number of the VH, chassis number of the VH, right? So these kind of few differences you'll be able to see under the running and the local configuration. Local configuration will contain little extra components. What kind, like I told you, that chassis, right? So this is the way that you will be able to see few extra configuration on the local part, right? Plus here you will be able to see some of the parameters related to what? Under the VPN interface part. Under the VPN interface part, you'll be able to see hello interval and the hello tolerance. Hello interval and the hello tolerance. So this hello interval and hello tolerance belongs to what? This belongs to the BFD. This belongs to BFD. Under the running configuration, you will not be able to see that. Under the local configuration, which is the default configuration available, you'll be able to see this hello and the hello tolerance. Right? So this belongs to what? BFD. So every interface will have this configuration. So if we further proceed, this is the interface gig 0/0. Similar way, you'll be able to see another interface that is gig 0/1. And you'll be able to see here also hello interval and hello tolerance configuration. We haven't configured, this is the default configuration which is available on the interface, right? And that's what is belongs to BFD, right? Like MTU. Did we define MTU? No. It's by default available, the MTU size, right? And that's what is the configuration available on each transport VPN 0 interface, not on the service VPN. This is not available on the service VPN. You can see this is the service VPN. The BFD configuration is not available on service VPN. BFD configuration is only available on the interfaces. Those they are the part of what? VPN 0, the transport VPN. So all the transport VPN, as soon as you will allow the tunnel interface, within the tunnel interface, you'll be able to see that BFD configuration. Are we okay?
Yes.
Right? So this is the default configuration which is available here. And generally, when we say that what are these two things, we say it is what? It can be even though configured separately in case if you wanted to configure it, right? And if you wanted to define it all together for every, you can say that VPN interface, you can even though define it under the system hierarchy as well, where we are configuring what? All these parameters. So we can look at here. Config tree, if I say system, under the system hierarchy, in case if you want, you can define some of the BFD parameters. But if you'll see it over here, you doesn't have after A, there is anything related to B. Can you see there is nothing related to B? So if I try to write BFD and I put a question mark, you'll be able to see this is invalid input. Right? But the latest iOS, this is the iOS onto which we are working right now. That is what Viptela iOS 18.4. And for Viptela, it was 19 and 20. There were two more versions available, but 19 and 20 both, they were what? They were released with the bugs. And Cisco has not actually worked onto those bugs. Instead, they have given the new solution, that is what the Catalyst SD-WAN. because there were so many bugs available in 19 and 20. Even though if I install 19 and 20 version here in the lab environment, you'll not be able to bring all the devices up. You will always see a new bug coming in. That bug is coming in. That's the reason the devices are not onboarded. Another bug, that's the reason devices are not onboarded. So the most suitable, you can say that version is what 18.4. Hence, we are working with 18.4 over here. Right? But in the latest versions, like I told you, 19 and 20, we have BFD options available, which can be configured under system, even though on the Catalyst, we can configure the BFD options available there in the interface, in the system hierarchy. Okay. So when we configure BFD, we configure two parameters over here. That is what the interval and the multiplier. Like that is what the tolerance, right? So interval is what the hello interval, and the tolerance is what? That's the multiplier, that how much time, or generally we used to say for the other, you can say for the other routing protocol, we say hello timer and dead timer, right? And we generally say hello timer is for the another routing protocol. Let's take, if I talk about the OSPF, 10 seconds, and the 30 seconds or the 40 seconds is what? The dead interval, right? But here what happens? We say this is the hello interval, that is 1000 seconds. But
Okay.
we define the dead or the tolerance as a number multiplier to the hello. So if the number is 3, then 1000 multiplied by 3, it means 3 cycles of the 1000. 3000 seconds will be the dead timer to declare the BFD dead. And BFD is dead, it means T-lock is dead. Is it right?
Okay,
So
got it.
that's the way these two values are there. And you'll be able to see that those values are by default available in the native iOS of the Viptela. And the same way you will be able to see these values under the system hierarchy in the latest iOS. So it might be under the system hierarchy, it might be under the interface, but it will only work for the VPN. It means for the transport, not for the service VPNs. And that's the way we talk about the BFD. Okay. And when we need to see the, give me a second. Let me come back, exit. So yesterday we were talking about show OMP, G-logs. You can see that how many T-logs have been received by this device, VH1 Site 1. So it is receiving these T-logs. So if you'll be able to see, every T-log has its own public IP, right? And the same is private IP since we haven't configured the NAT, right? Plus, when we look at it, what from which peer it is being received? One is local T-log, others are received from the vSmart, right? And when we see the T-logs, you will be able to see the first T-log is up, that is received locally. Other T-log is up, that is received from system IP 55. And the color is MPLS. But the T-log, those are being received from BIS Internet, they are down. The status is down. The T-log, which is received from the same system IP 8, one as an MPLS and one as an what? BIS Internet. MPLS one is up, but BIS Internet one is down. Right? So you can see the status here itself, you will be able to see about the BFD that, okay, either it is up or down, or based on that, you'll be able to see the IPsec connectivity, up or down, right? So we say show IPsec. After that, you can see what? Inbound connection, outbound connections, right? So if I say outbound connections, you will be able to see that where exactly these outbound connections are going. Only to those where the BFDs are up, only those connection is going to get up, but it'll send all the connections, be it is MPLS or be it is what? BIS Internet, TLOC, it is going to send all the connections. It means it is going to send the request to all the TLOCs. And you can see that it is sending via this key hash, via this encryption, via this algorithm, right? This is the SPI. Every information you'll be able to see. Okay. So be it is MPLS or be it is BIS Internet, everywhere you'll be able to see what? The outbound connections are there. Similar way, you'll be able to see the inbound connections, which those they are coming in to this particular device. So even though inbound and outbound, both the connections are coming from all the transports. You can see that TLOC IP 5, 6, 7, 8, from every device they are coming in. But which one is going to come up? Only those they are with MPLS. Are we okay? You can see the physical IP addresses from which you can see the IPsec connections are being initiated, and this is the local IP where these are being received. Okay. And that's where, and this is something which helps you when you have to do the troubleshooting task. When you have to see that either are we receiving the IPsec connections or not? If we are not receiving the IPsec connection, how the IPsec tunnel is going to come up? Okay.
Got it.
Right? Sometimes what happen, your PFD is up, still IPsec is not sending the connectivity. Okay, so you need to look at all possibilities when you are moving towards the troubleshooting. So these protocols like OMP, BFD, IPsec, they helps you to perform troubleshooting. Otherwise, you need not to do any configuration for OMP. You need not to do any configuration for BFD. You need not to do any configuration for IPsec. All these are by default intact there as per the factory default settings. Only the scenario in which we are doing the protocols in service VPN. Like example, we are configuring BGP in the service VPN, or we are configuring the OSPF in service VPN. Then we need to do what? A redistribution in the OMP, right? Since by default OMP is what? When I showed you the configuration, it is what? It is only advertising the connected and static routes. It is only advertising the connected and static routes because the solution is meant like that only. But in case if we configure within the LAN, let's take an example there that the edge site is what? It's a data center, and within the data center we have a lot of routers behind it and all they are running the BGP, or all they are running within the same AS OSPF, then what we need to do, we need to advertise all those LAN prefixes from OSPF to OMP. So we do within the OSPF redistribution of OMP, and within the OMP we say advertise OSPF. Only this is what as an exception which we need to configure. Else we need not to perform any configuration related to these protocols. Are we okay? So this is, I showed you from CLI. When you need to do troubleshooting, then only you jump to CLI. Otherwise, you generally remain here on this particular part only. And from here itself, monitor network. And from here itself, you get to know either the BFDs are up or not. Right? You get to know about the control. You get to know about the BFD. And based on these BFDs only, you'll be able to see tunnel. If I come back to this VH1 site 1, there are 2 BFD sessions up. And you'll be able to see based on this, there'll be tunnel. That is what WAN tunnel. You can see only 2 tunnels are up and 3 are down. Right? And if you see the 2 tunnels, those they are up, those they are with the same color and they are up. And the other, those they are with different color, MPLS and the BIS internet, MPLS and the BIS internet, MPLS and the BIS internet, hence they are down. And you'll be able to see here, the tunnels, those they are up, onto that, what is the status of jitter loss. Right? Based on this, we define that which one is what the best path in case if we are having the same, you can say that the path available to multiple paths available to the same destination. Okay. So most of the troubleshooting, we do it from here itself. And we have the options to execute all these commands also from here. That's what when we do troubleshooting. We can view it in the real part as well as we can view it in the real time. What are the commands we wanted to execute? BFD history, BFD session, BFD summary, BFD T-log summary, all these commands. These 4 commands are only there. Right? So BFD sessions, from which IP to color, you need to define the source and remote and the system IP. Right? And similar way, you can run the BFD summary. There are total 5 sessions, 2 sessions are up. Right? There is nothing such as an flapping. Similar way, you'll be able to see what? BFD T-log summary list. It's initiated from gig 0/1 interface. Encapsulation is IPSEC. Current number of BFD sessions 5, but the up state is only for 2. Right? And similar way, you'll be able to see here the BFD history. You need to do not filter. Simply have a look at it. That which one is up, which one is down. If in case anyone went down and then came up, you'll be able to see that too. MPLS state was down and MPLS state is up. So that's the history. You'll be able to see it. And similar way, you'll be able to see session also if in case I do not apply the filters. What is the current BFD sessions? Are we okay? So I showed you from CLI as well as I showed you now BFD from the GUI. We have seen IPSEC inbound session, IPSEC outbound session. Based on BFD only there are. And the similar way, if I need to see here about the IPSEC, you can see that IPSEC parameters here as well. What are the local assays? What are the IPSEC outbound connections? What are the IPSEC inbound connections and outbound connections and local assays? So let me show you here. This is what the local security association. This is the TLOC address, this is the color, this is the SPI, this is the source IP by which it is going to establish the security association. So whenever you would have studied, let's take an example. I come back over here on the Google. I say that, okay, IPSEC protocol phases. Can you see it has two phases available, right? The first phase does what? It creates a secure tunnel to protect the negotiation process, while phase 2 builds the actual IPSEC tunnel, right? But here in the SD-WAN scenario, the initial negotiation process is not being done by IPSEC. It's being done at the time of control connection only. At the time of control connection only. So what happens if I open a notepad? What happens when let me draw it. Let's suppose we have this as a data center. And within this data center, we have vBond as the first authentication device. Then parallelly, the connection is being established with vManage and the vSmart, right? So we say that connection is with vBond. Then vManage and then with the vSmart, right? And we have a VH available here, which is connected with some, you can say that the ISP. And via that ISP, it is connecting to this data center. And from the data center, all these devices are connected. Right? I say that this is the WAN edge. Now, this WAN edge device will be establishing one control connection, first of all, initially with what? Initially with vBond. What is the reason behind it? Because this is the first point of contact for validating, right? Validation will happen, then the authentication will happen. After the validation and authentication, this vBond is going to share what? Going to share the detail of vManage and vSmart, right? So vBond is going to validate And after validation and authentication, it is going to provide what? The detail of vManage and vSmart. Now, authentication is being done how? Tell me now, how the authentication is being done between vManage and vBond. Validation, I told you, with the help of what? Serial number, chassis number, and the serial number, right? Which we are manually providing in the lab environment, right? And authentication is with the help of certificate. Is it right?
Yes, ma'am.
So it is using the PKI infrastructure to have the authentication. So we have a appropriate root CA, and that root CA has issued the certificate to vManage, and that the same root CA has issued the certificate to vBond, right? So they belongs to same CA, and they have their own certificates, and they exchange their certificates. And while exchanging their certificates, what they exchange? They exchange the private key or public key. Which key they exchange?
Private keys.
Private keys they keep them with themselves. Private keys are secure keys. Public keys are being exchanged.
Okay.
Right? They are exchanging the public key for the authentication. And once that authentication is successful, the tunnel is ready. And after that, within that tunnel, vManage and vSmart IP addresses are being shared. Right? And once that is done, the tunnel between the vBond and the vManage is what? Since it's a transient tunnel, it is what? Deleted. What will happen now? Now it has received the information of vManage and vSmart. The vManage is going to establish the tunnel with what? vManage as well as with vSmart. Right? So the use of the tunnel, which is there with the vManage, what is the use of the tunnel? Config push and monitoring. That's what the vManage does. All the advanced configuration can be pushed from the vManage to vManage, as well as all the parameters. Which parameters? The monitoring statistics are being exported from vManage to vManage. Hence, we can monitor them via the vManage. Yes? Is it okay? That's what is being done by vManage. And what is being done by vSmart once the validation and authentication is done? The OMP, right? So we generally use say OMP performs what? Routing, right? So all the routing information is being provided by vSmart to the WAN edges. And on the basis of that only, WAN edges starts working, right? The TLOC information is being shared via the OMP. And based on that, TLOC BFD works. Now BFD gets to know that, okay, these are the TLOCs, those they are up, or these are the BFD sessions, those they are up, onto which IPSEC has to establish the session. Apart from this very important information, when vManage has authenticated with vSmart, vManage has already provided its what? Public key to vSmart. When vSmart is sending the routing information, along with that, it is also providing the public key as well. Hence, negotiation is not required when a vManage is trying to establish IPsec connection with another vManage because the key has already shared along with the routes. So phase 1 is no longer required. Phase 1 is no longer required. Are we okay? Is it okay? Are you able to understand this part?
Yes.
How the negotiation is being done? Negotiation is being done on the basis of the keys, which we are defining in, right? IPsec is using password mechanism. IPsec is using PKI infrastructure. When it is using the PKI infrastructure, within the PKI infrastructure, public keys is exchanged in the phase 1. And here, there is no need to exchange the public key since public key is already available with the vSmart. And when vSmart is sharing the routes when vSmart is sharing the T logs, along with that, it is also sharing the information of public key. So for all the T logs, VANEDGE is having the public key. Hence, phase 1 is not required. Only they need to have phase 2 negotiation. Only they need to have phase 2 negotiation. So if I say that here, we have the other VANEDGE, and let's suppose it is also connected with the same ISP. So both the VANEDGEs, this is VANEDGE 2, both the VANEDGEs will receive the public key from the vSmart. Remote VANEDGE public key. When I say remote VANEDGE, it means what? VANEDGE 1. And here, remote VANEDGE, it means remote VANEDGE 2. Public key is being received from the vSmart itself. Now, no longer phase 1 is required between them. Only phase 2 negotiation will happen. And once the phase 2 negotiation is successful, IPSEC tunnel is established. Hence, we say it's a partial IPSEC. Only phase 2 negotiation is required. And for phase 2 negotiation also, we need not to do any configuration. When I showed you the configuration, running configuration or the local configuration of VANEDGE, you can see that there is a phase 2 policy pre-configured as per the factory default settings. We need not to do any configuration for it. Is it okay? So take a screen capture of this. You'll be able to see, or you'll be able to remember this public key exchange has happened via the vSmart itself. When a route travels, the way we say that BGP has mandatory attributes AS path, origin, and next hop, right? The similar way, OMP is having an attribute. That is what it will carry the public key. It will carry the TLOC of every prefix. It will carry the public key of every prefix. Okay?
Yes, ma'am.
Clear? So please take a screen capture and post it. And that's it for the day. Since we need not to have any configuration, we can only see that they have the IPSEC connection and they can reach to each other. And in the upcoming class, you guys have to remind me as soon as I start the class immediately on Saturday that we need to do zero touch. We'll be doing zero touch. And then we will be proceeding with the next topics, such as what we need to do that's related to advanced parameters. We need to do template. We need to do TLOC extension. We need to do policies, right? Hopefully by December mid will be winding up. Right? So please, I'm saying that in case if the configuration is deleted, that's what I'm doing it for purposefully. So that you will practice again. Okay? So if you feel that, okay, you wanted to remain with the smaller topology, you can remain with the smaller topology, right? I'm clearing all this off and coming back to the topology part. Let's stop this here. More actions, stop all the nodes. I'll show you that this is the smaller topology. In case if you feel that you doesn't want to configure the bigger one, it's up to you. Let me close this. And this one is the bigger one that's named with SDWAN September 2025. Sharon, for you, it's this one is the topology. So the benefit of this topology is what? You'll have a bigger scenario, as well as you'll be able to configure V edges with dual ISPs, and dual V edges will be there. And to have their redundancy, we need to configure here the VRRP protocol. We will have the scenario of TLOC extension here. We will have the scenario of the LAN OSPF and LAN BGP routing. So this is only the benefit. So some of the, you can say the things which we cannot configure in previous topology, only those things we can configure over here. Right? Until now, the smaller topology was fine. But for the next parameter, I expect that this topology needs to be configured. But in case if you feel that it's too much, leave the site. Leave the site. Right? So configure site 1, configure this site 2, site 3, and site 5. Leave site 4. Okay? Is it fine?
Sure, ma'am.
So it will be again little smaller scenario. Because you need to achieve the things. So we can configure TLOC extension here, we can configure OSPF here, and after configuring the OSPF on the same, you can configure the BGP. Remove the OSPF and configure the BGP, and you'll be able to achieve the things. And keep handy the configuration at your own level. Like what you are doing it on vBond, vManage, vSmart, keep it handy. Okay. I remember, Yusuf, you have created some nodes. Yusuf is in or not? Yes, he is in. You have created
Yes,
some
ma'am.
nodes for controller configuration.
Yes, ma'am.
So are you doing it for
Yes.
the rest as well?
Few of the class I missed, no, so that is only missing. Other I did already prepared.
So share it with everyone in the
Okay, ma'am.
WhatsApp group itself, right?
Sure, ma'am.
Whatever is ready with you, share it with them.
Okay, ma'am.
Okay. And
Sure, ma'am.
whatever is left behind, that can be done by anyone else.
Ma'am, I have one question. I'm sure you will get angry on me because I'm asking very late.
No problem. You can ask.
Can I share my screen?
Yes, of course. Let me stop sharing.
Hope my screen is visible, ma'am.
Yes, it's visible.
Okay. So, ma'am, controller are integrated already.
Yes.
For the edge device only not showing here. The chassis number and all need to do something, right? By
Right.
watching your video, I did this, but I'm not sure it's not integrating.
Okay. So what you need to do, you have the certificate installed on the WAN edges.
Yes, ma'am.
Okay. So log into, right now you're on vSmart, exit from here. On the QM only.
Okay, I will. Humanly, okay.
Yes. Right. Exit.
Just a second, ma'am. It's loading, ma'am. 1 second. it is just start. I'm using this PC for morning now. Maybe I stuck.
Okay. That's the reason. Yes. So what you need to do, don't stop and start like that. You will lose your configuration. So what you need to do, you log out from this. Log
Completely.
out from this. Yes, log out, not close. Not close. Log out.
I need
The
to
last.
stop it, otherwise it
No,
will.
no, 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 no. Log out. So it
Okay.
says that you cannot log out. So simply close the browser, log in again.
Yes, ma'am. Re-login.
Now refresh your topology. Oh, from the refresh button. Yes, now log into PC. Now, if you see putty is inactive from the top, restart the putty
Oh,
session.
yes. Sorry. It's a basic mistake.
Sometimes what happened, we do not realize what exactly is the challenge. Even though I did
Yes,
not
ma'am.
notice that putty is inactive. So now you are on vManage, say vshell, enter, log into the any vanage -L,
Yes, ma'am.
admin,
10,
yes.
20,
No, that is not 10,
20,
that is 20 or 30, yes, 20.
What was the subnet?
20.00,
Yes, ma'am. 20
5 or
dot
6 IP will be
0
00
6.
6. Okay, enter. Admin. Say show to see the chassis number and see serial number. Show certificate serial. Copy this. Yes, it's copied. The complete. Just select the complete one. Open a notepad on the same PC. Yes. Open a notepad on the same PC. Paste it now here. Yes. Now you have these things, right? Now exit from this Vantage. Now log into vBond. No.
Okay.
On the V. Yes. Log into vBond. SSH-L. Admin. 10.002.
Ma'am, I have given separate IP to remind myself.
Okay. No problem. That's good. You are on vSmart.
Yes, ma'am.
You are on vSmart. Log into first vBond. The first authenticator is vBond. It's a vSmart.
My mistake. Correct.
It's okay. Now request vAjad. Chassis number. Now copy the chassis number. Space serial number. Bring the serial number.
Like this only, right?
Yes, like this only. Copy. Yes. Press enter. Now exit from here. One more time exit.
Yes.
One more time exit.
Yeah.
Copy the command from top. No. Copy the command from top and paste it over here. Yes, enter. Now again we shall go to vSmart. SSH-L admin 10.12.1.4.
Admin.
Okay, correct.
Paste the command.
Same
command. Yes, now come back to dashboard. Refresh this dashboard.
Ma'am, actually, first of all, he has to install certificate and
certificate. Let's see that. Let's see that.
Let me verify, ma'am. That part I did.
Hold on. Come back to dashboard.
Yes.
Come back to dashboard. I'm just thinking that you have done everything right? So if you have done everything right, then it should come over here. But if it is not coming over here, so we need to start troubleshooting. And for troubleshooting purpose, first thing which you need to do it, that is what you need to go to the administration settings. Settings. Yes. Validate here. Controller certificate authorization is this enterprise, and this is automated. Perfect. It is for the edge is automated, and for the controller certificate it is enterprise. Can we check Vantage edit? Vantage certificate.
Here itself. Okay.
Yes, Vantage certificate edit. If you see, automated is what via we manage only. It's correct, right?
Yes, ma'am.
So that's it. Cancel it. We are not making any change to it. This you need to validate first of all, right? This is the first troubleshooting part. Second troubleshooting part is what you need to check on the Vantage. Do you have a root CSRT installed or not?
Yes, ma'am. Let's verify now.
Yes, let's verify.
So certificate. Yeah, it is assigned by me.
It is assigned by you. Correct. Now check the certificate. The certificate.
So certificate. Serial.
Yes.
Okay.
So both the things are there. Right?
Yes, ma'am.
Now check show control. Show
So-
control.
Okay, 1 second. It's taking time.
On the same device.
Yes, ma'am, but it's not. Second. Let me try from here. Stuck, ma'am.
It's okay. It's okay. Show control.
Okay, I think I need to wait for a second.
You can refresh the lab. Still the lab is running slow, right?
Right.
Maybe all of you have logged in.
Yes, ma'am. So
Control.
control.
Question mark. So if you will see local properties, that is the command for troubleshooting purpose. Show control local properties.
I have typed it. Just a second, ma'am. It will load.
No problem. Yusuf, what is your, you can say that the,
Local properties. After that.
that's it. So if you will see here, personality
properties.
VH, organization, certificate installed, root CA installed, certificate validity, DNS name, site ID, domain ID, TTLS.
What is the DNS, ma'am? I have not mentioned it.
That is VBond.
B1. So B1 IP is different here. My IP is
Yes.
10.2.
Yes. So that's the challenge here.
Okay. Then need
Okay.
to go in.
Once again, execute the same command. Execute the same command.
So control local properties.
Right. And space bar. I wanted to see complete output of it. If you will be able to see the connections, can you see that connection is shown as an what? VBond PR1 and the IP address of the VBond is 10.0.0.2.
Where are you seeing?
Yes, this one.
This one.
No, last from the above table.
Last from the table. This line.
This little more up, little more up. Up, 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 up. More up,
Here?
more up, more up. Before this, yes. VBond PR1,
Okay.
and this is the
PR1,
IP
yes.
address of the 10.0.0.2 is the IP. Down to this,
Correct.
yes. So this is the challenge. That's the reason it is not coming up. Okay.
So the number should be how much it will come? Correct?
The number of VBond PR must be one only, but the IP should not be this because in your scenario, different IP is there.
Correct.
Correct. So check the
Yes, ma'am.
System configuration. Check the system configuration. No, show.
Here also we can see, right?
Right, you can see.
Yeah.
Got it? So
Shall I change, ma'am?
VBond, yes, of course, VBond is not able to authenticate.
Yes, ma'am.
But first you need to say no to that VBond.
Oh, okay, okay. Like that, huh?
Say no. Here only, say no.
Otherwise, it will take two
VBonds.
V1 IP.
Right. So
right now, I think something happened. Okay, might be this part already gone. Let me check.
yes, let's check. Validate it, okay?
Yes, ma'am. So full configuration. Okay, it got changed already, ma'am.
It
That
got
is why.
changed.
Need to see.
Now,
Yes,
now
ma'am.
go back and check the PC.
Shall I commit?
Yes, commit and
Okay.
quit. Yes.
Now same config. What was the command? Configuration, right?
Right. Show control local properties. Show control local properties. It's changed now DNS name,
Yes, ma'am.
right?
DNS name also changed.
And press the space bar. Press the space bar. Now show control connections.
So control connections.
Connections.
Hmm.
Now connections
This
are
is-
up.
We manage.
Right.
We smart.
We want. Right. Now go back and see on the PC. This would be updated on the dashboard. Configuration devices.
Yes, ma'am. Coming here.
Coming here. Done.
Yeah. Yes, ma'am. Now I will do
Select
other part. Monitoring.
other part as well.
Yes, ma'am.
Yes. Now you can do rest of the things.
Yes, ma'am. Yes, ma'am.
It's done. So it means you have not completed your lab yet.
Yes, ma'am. I missed two to three class continuously, ma'am. Even that certificate class also I was recorded only.
Okay, no problem. But now please complete this and be from the next week onwards, be on the same pace. Okay.
Sir, ma'am. I will come to same page.
Sure.
Yeah, ma'am.
Okay. Thank you,
Thank you, ma'am. It
everybody.
was wonderful.
Yes.
Thank you, ma'am.